Greetings, I am Randy 2.0 of Oinki Do Academy. Today I'm with Ting and we're going to do a science experiment. Ting, you look familiar. Have I seen you somewhere before?
Yeah, I'm your son.
My son? Are you the guy always hanging around the house consuming resources?
Duh.
I have two sons. Which one are you?
Grade 6?
Grade 6, so you're the younger one. Does the older one ever pick on you?
Every day.
Every day? Man, your parents should really do something about that.
Hello?
Ting, what kind of science experiment do you want to do today?
Maybe cold chemical reaction.
Chemical reaction. I have an idea. How about we show you a variety of chemical reactions and you score them from 1 to 5.
Okay, let's start.
Let's start. Okay, I think the scoring system should be level 1, tranquilizer dart. Level 2, yawner level. Level 3, not bad, not bad. Level 4, pretty good. And level 5, reaction satisfaction.
Let's start.
Ting, this is a classic science chemical reaction they teach in school. All you got to do is dump this vinegar into this baking soda solution. Go ahead and give it a try. You can dump the whole thing in. What do you think?
Lots of bubble, but not too colorful. I think it's a yawner level for that.
Yawner level, I think you're being generous. If you're willing to wear some gloves and maybe some goggles, we can do some redox reactions which have more colors and some of them are even reversible.
Hand me the gloves.
Ting, this first redox reaction uses a solution that has water, potassium sodium tartrate, and some copper sulfate to give it the blue color. And then we're just going to dump in some hydrogen peroxide and see what we get. Want to give it a try? Just dump the whole thing in. And you can see the color changes. We get some good bubbles. It's a lovely turquoise. And uh-oh, what's happening there? Kind of a greenish. What do you think of that color?
Brown?
Brown. What does it look like?
Diarrhea?
It does look like a bit like diarrhea, huh? I think I've produced some similar looking fecal matter. The good news about this one is that it's kind of reversible. So if we dump in some more hydrogen peroxide, we can hopefully bring that nice turquoise color back. And give it a try?
Okay.
All right, looks fairly stable at this point. Let's dump that in.
Oh, the
More
turquoise
bubbles.
back.
Yeah, that color looks great. If it just stayed that color, that would be perfect. Got some good bubble action. I think even better than the vinegar and baking soda bubbles.
Yeah.
Yeah, this is a great color there. And so far, uh-oh. All right, that's kind of a nice looking green. It looks like it's stabilizing to green a bit. I don't know if that brown's going to show up again. Let's hope it doesn't, huh? Well, what do you think about this one? First we suffered through that brown color, but we did get a very lovely turquoise. What do you think the level is for this one, Ting?
I like the turquoise and the bubbles, but the brown, I give it a not bad level.
Not bad, not bad. All right, so I think we have some room for improvement. Okay, Ting, for this redox reaction, we're going to add some potassium permanganate to this alkali solution. And I'll just add a little bit to try to give it some purple color. It's kind of pretty as it drops through there. Stir that around. Okay, that looks pretty good. We should be able to see some color change from that. So next, we just want to dump in this sugar water and see what kind of color changes we get. Go ahead. Flash of blue, and then it went to kind of green.
Yellow.
Yep, transitioning to yellow, and looks like it's still going. Looks like some red has entered the picture.
Amber.
Yeah, that kind of looks like a nice amber color. It looks kind of stable at that point. You think we should try to reverse it?
Yeah.
Let's see what happens. I doubt we can get back to purple, but maybe we can get back to some of the other colors. So let me add a little bit back in. And yeah, you can see it's kind of purple for half a second, and then it's trying to get back to the green. It doesn't seem to take very long for it to migrate back to yellow again. You can see that cloud of potassium permanganate in the bottom where it's kind of green. swirling around inside of the amber. All right, let's try it one more time. That's quite a beautiful color there. Let's see what happens if we add some more. Okay. Color may get too dark to where we can really see what it is. I mean, that kind of looks like a turquoise there. And it's starting to lighten into that yellow thing. So this one's quite difficult to completely reverse. We cannot get back to the purple. We can get some colors back, but some of them become too dark to really see, although the final color ends up quite nice with that red look. What do you think, Ting? What should we give this one for our reaction satisfaction score?
Maybe pretty good.
Pretty good? Because we like the colors, there's no diarrhea color in there. All right, and a little bit of reversibility. All right, how about we prepare for the next redox reaction since we got a pretty good out of that one. Okay, Ting, for this redox reaction, we're going to wear goggles because we're going to need a blender, all right? And it looks kind of boring because we just have this alkaline sugar solution, but there is something called methylene blue in there. And so why don't you take the blender and see if you're strong enough to get the blue out by blending it. Make sure you shut it off before you take it out, otherwise it'll be like boom, boom, boom. Oh, I can see a little bit of blue coming out.
It's turning blue.
All right, keep attacking. All right, I think that looks pretty good. Let's see if your team is victorious. Oh, wait, it looks like the white team is tearing apart your blue army. What do you want to do?
Use the blender to bomb again.
You want to bomb it again? All right, bomb it again with the blender. All right, so as long as we're getting oxygen in there, the blue team will take over and turn the methylene blue back to blue. All right, that looks pretty good. Looks like blue team won again. Uh-oh, looks like blue team is just too weak though. It's slowly turning back to clear again, although not as fast this time. This one depends on the temperature. If the temperature is hot, it'll just go back to clear really quickly. If the temperature is cool, it can take a long time. So how about we blend it one more time. It looks like clear team won again, but this time, how about we add some cool water to it? Okay, got a little bit of oxygen in there, just adding the water. So go ahead and blend it back to blue. There we go, get some good gurgling action. That'll get a lot of oxygen in. All right, that looks pretty good. Let's stop there, turn off the blender, and let's see if that takes a little bit longer for the blue team to claim victory. I don't know, looks like clear is slowly taking over. Blue's hanging in there. Good thing we both have our blue shirts on today. I'm kind of cheering for Team Blue.
Big purple.
One big bubble in the top. Well, I think we should declare victory. I think Team Blue has won by adding that cool water. What do you think about this experiment, this reaction?
It's a little bit boring because only got blue and clear color, and clear is not even a color.
Clear's not even a color, right?
So I will give it a not bad, not bad.
Not bad, not bad. But at least it was a little bit satisfying to get the blend, right? You got your team in there digging away.
Yeah.
All right. But it looks like your team lost in the end. So how about we try one more? We'll try another one with a blender, but see if we can get more colors this time.
Okay.
Okay? Okay, Ting, redox reaction number 4. You can see we're starting with yellow color this time because we decided clear is not really a color, right? Let's see if we can get more colors out of this one. Basically, we have a sugar alkaline solution with something called indigo carmine inside, and hopefully that will be enough to bring out some colors when you blend it. And give it a try. Why don't you start with this small one because I worry the blender's maybe not strong enough for this big one. Let's start with the small one. Ooh, can already see some orange and there's some green. See if you can dig the green down to the bottom. I think you got it. Why don't you stop there and see how your team does. Remember, Team Blue ended up in defeat by Team Clear. Let's see if Team Green does any better. While we're waiting for that one to change, we can probably go ahead and try to blend this one. I see a little bit of red showing up in that one. Let's see if we can get to the same green level. Oh, yep, I think it's going to work. All right, that looks green too. And it looks like this one has gone through several color changes. We've gone through some red into oranges, and it looks like it's heading toward yellow. We'll see if it makes it that far. This one's just beginning its journey. I can see some red starting to materialize sort of in the middle. We'll give it a minute and see what color it ends up. Oh, that looks great. It actually happened pretty fast. It went from green to kind of orange, amber looking. This one has made it all the way to its final state of yellow. And this one's almost there as well. You want to give it one more shot? still quite reversible. Back to green there. And this one you can do quite a few times, reversing the color from green back through the reds and oranges and yellows. What do you think, Ting? What level should we give this one?
The highest.
The highest level, number 5, because we have lots of cool colors and we have satisfaction from blending, right? So it looks like we have achieved reaction satisfaction, level 5. Well, I think we'll probably stop there then. If you're interested in learning the science about this reaction or any of these reactions, you can go to Oinki Do Academy and take the full redox reaction course. It's it, and that's that. Thank you, Ting. See you in the future.
Bye-bye.